Thank you for your interest in this Future of Work related presentation. My name is Marilyn Barger, and this work is part of a National Science Foundation Advanced Technological Education funded project. This presentation's intent is to mimic an ASEE poster session. The slide content is provided with the idea that you can use your video pause button when you wish to spend more time on a slide. The future of work at the human technology frontier is one of NSF's new 10 big research ideas. This framework includes the study of the intersection of future workers, future work, and future technologies. It also will look at enabling creation of technologies that can collaborate with humans to enrich our lives and workplaces. Our specific project, Preparing Technicians for the Future of Work, deals with the impact of new technologies on two-year degree technician workforce. You can read 5 focusing points for our project on this slide. Our project is examining several advanced technology sectors of interest to the NSF ATE program. The discussion in our presentation is constrained to the skills and knowledge adjustments that technicians working in the manufacturing sector must deal with. There are many technologies identified within the concept of Industry 4.0 that will affect technician education and technician performance in the future. We will be using edge computer technology in this specific example later in this presentation. However, here are 4 snapshots to help tighten our discussion of these technologies. On the upper left, individual red lollipop wrapping is a novel robotics application that reflects customized production. It is also an application that can be adjusted to make COVID-19 masks. A technician is the person that would implement and calibrate adjusting the equipment. On the top right, we see a warehouse that is elegantly neat and operationally effective. However, the operation pays a lot of attention to cross-skilled technicians working behind the scene. On the lower left, the technician in the automation photo is performing typical work related to process equipment, interfaces, and operations. The interesting new tool at his disposal is access to the equipment and its expectations through a laptop control panels where he must interact with a number of machines working together in series. The last picture on the lower right reflects the most subtle new skill expected of a process technician. Clearly, it shows a relatively massive process operation underway. However, if you examine the peripheral regions of this scene, there are several information centers providing different data about the processes to the technicians and advanced operators. There's also a heliograph of the position target in the upper center of the photo. Our project for the future of work is gathering information from a number of sources. This includes the list you'll see on this slide. We have an industry advisory committee that we access regularly. We have been doing industry site visits to different facilities across the country. We've accessed the NSF ATE Leadership Caucus. We also have interviewed technicians and supervisors in the field. We've conducted a number of focus groups for industry and education. And we also are doing research in business news on the future of work. After reviewing and analyzing the information we've gathered from the various sources previously listed, 6 high-level observations have bubbled to the top. The next slides share these observations with you. More cobots and robots with more functionality are appearing everywhere and very quickly. More edge computing automation is also showing up in facilities across the nation. There's much more communication among equipment. Continuing with the observations, Number 4 is that we've observed more interactions across technicians, operators, supervisors, and administration in different facilities. And number 5, this definitely leads to the need for more refined employability skills. And lastly, number 6, smart machines are getting smarter. This implies that the technicians will also have to be smarter and more knowledgeable about the work they're doing. With these 6 observations, our project has framed a single guiding question for our work. You'll see it on this slide. Are there new foundational skills for the next generation engineering technology technicians? During our project's first year, our research and our activities revealed 3 important skill areas that will impact the future of work issues for technicians. You'll see those listed on this slide. Skill Area 1, Data Knowledge and Analysis. Skill Area 2, Advanced Digital Literacy. And Skill Area 3, Business Knowledge and Processes. The foundational skills in these 3 skill areas fit neatly at the lower levels of the Department of Labor competency models for a number of advanced technologies. The cross-disciplinary nature of these skills make them a particular focus for our project, preparing technicians for the future of work. To establish boundary conditions and to focus our work in these emerging skill areas, we have adopted the working definitions you'll see on this slide. Please take a moment to read them before we progress. Digging a little deeper into each of these 3 skill areas, this slide and the next one will give you some of the topics that have bubbled up for each of the 3 skill areas. I'll give you a couple minutes to read through some of these example topics. Our presentation will circle back to the communications topic under Advanced Digital Literacy on the previous slide, as we now move into our example dealing with edge computers.
Now, let's shift our attention to an advanced digital literacy condensed example that involves edge computing. Edge computers are a valuable new critical operational component in medium and large manufacturing companies. They provide 2 important functions. They selectively insulate equipment from the cloud, and they analyze information and then provide specific operational guidelines directly to the process equipment, which in turn creates a new troubleshooting challenge. When there is a problem, is that problem with the specific process equipment, with the information provided by the supervisory and or the edge computer, or is it a communication failure? Today, our attention is on the failure scenario. Conceptually, the communication objective is to move information back and forth through various layers and locations along the path between the edge computer and the process equipment. An encapsulated datagram is assembled in the host and then begins a handshake trip through a link layer switch, a router system, to a target server, which in turn inserts new instructions to the process equipment. There are challenges along this communication path for educators as well. It's not clear if the language used in this example is uniformly used in the network community. It's not clear what the role or roles of the 4-year and 2-year professional technologists, engineer, and technicians are. And finally, it's not clear if it is the same technician involved in the complete datagram transport process. For Florida, the AS Engineering Technology degree program is the vehicle to address this example. This 2-year program has several useful properties. It also has multiple entry options as well as multiple exit opportunities, and It articulates to the BS in Engineering Technology degree that also leads to a professional engineering status in Florida. The program fine structure is shown here in more detail. Yes. The core course specifics are shown here on a larger scale. This first year of study includes microcomputer applications, engineering graphics, introduction to quality control, instrument techniques and measurements, manufacturing processes, and industrial safety. CGS 1100, microcomputer applications, is used in our communication example. The program's manufacturing specialization is also the tool for this communications example. Its course portfolio includes automation, process control, industry applications using PLCs and robotics, introduction to PLCs, hydraulics and pneumatics, motors and controls, mechanical devices and systems, and a technical elective. Our communications example will use the ETS 1540 industry applications using PLC and robotics, and the ETS 1542 Introduction to PLC courses. As with any engineering task, practical constraints or limitations are imposed to reach a useful solution to the task at hand. In this case, the technicians will be working under the following operational constraints. They will deal with TCP as governed by a RFC standard, and if they are dealing with a proprietary system, its structure will be related to RFC practices. The technology itself also provides general practice guideline assistance. RFC protocols use well-known port numbers. This means that the technician must recognize how these port addresses interact with the code they are examining. With all of this foreground structure in play, background learning objectives were developed and shaped as lessons and projects that complement the expand scope of work in CGS 1100. More advanced and equipment-specific communication concepts are inserted in lessons in ETS 1535, ETS 1540, and ETS 1542. College credit limits curtail the first plus approach. Simply add a new course. Instruction has to follow program constraints. If new content is added, it's likely old content will have to be deleted. Blending new content as constructive conscripts in existing courses is a challenging but rewarding approach. It accents applications of concepts being studied. It provides repetitive concept presentation in multiple courses, and it expands possible complexity of capstone projects.
Thanks.
For your attention.
We really would like you to share any of your own experiences in these topics of the emerging skill areas for the future of work. Please contact us.